Welcome back. We are continuing with the laws of motion chapter. Last class we saw different cases in which lift is going accelerating upward, accelerating downward, when the lift cable breaks, when the lift moves with a constant velocity. Now in today's class we are going to do a problem based on this lift case. A child of mass 20 kilogram is in a lift that is moving down with an acceleration of 5 meter per second square. What will be the apparent weight of the child? What will be the apparent weight of the child? Apparent weight of the child. What will be the apparent weight of the child? G is equal to 10 meter per second square. What will be the apparent weight of a child? See, lift is what? Child mass is what? 20 kilogram. It is accelerating downward with an acceleration of what? 5 meter per A equal to 5 meter per second square. What will be the apparent weight? When the lift accelerates downward, what is equal to apparent weight? mg minus ma, or you should write m into g minus a. Here given mass is equal to what? 20, g is equal to what? 10, and acceleration is equal to what? 5. So r equal to 20 into 10 minus 5. So r is equal to 20 into 5. So normal reaction is equal to what? 100 Newton. Any doubt? Any doubt? Problem മനസ്സിലായോ മക്കളെ? All of you, good evening. Shaji, Abhinav, Arati, Adira, Vijusha, Sri Shakti, Arjun, Anugraha, Sanusha, Nandagopal. All of you, good evening. Please note it down. Apparent weight is what? Normal reaction. 100 by 10 ചെയ്യേണ്ട ആവശ്യമില്ലല്ലോ ആരതി. എന്തിനാ 100 by 10 ചെയ്യണേ? Weight is mass into gravity, right? So what is apparent weight? 100 Newton. Done. Next question. A monkey, it's a textbook problem. A monkey of mass 40 kilogram climbs on rope which can withstand a maximum tension of 600 Newton. In which of the following cases the rope break? First one, the monkey climbs up with an acceleration of 6 meter per second square. Second is monkey climbs down with an acceleration of 4 meter per second square. Now answer. First is the acceleration is what? 6 meter per second square. When the monkey climbs up, normal reaction will be what? M into G plus A. What is the mass of the monkey? 40 into G is we are taking as 10 plus 6. So 40 into 16. So answer is what? 40 into 60. So 640 Newton. So what is the maximum capacity of the rope? Maximum tension of rope. Maximum tension is only 600 Newton. So when the monkey climbs up, rope breaks. Because when the monkey climbs up, what is the tension? It becomes 640 Newton. And what is the tension in the rope? Rope can withstand only a tension of 600. So when the monkey climbs up, the tension in the rope is greater than what? 600. So what? The rope breaks. Climbs down. Monkey climbs down means what? Acceleration is equal to what? 4 meter per second square. So normal reaction are equal to what? M into G minus A. So 40 into, what is the G value? 10 minus 4. So 40 into what? 10 minus 4, 6. So answer is what? 240 Newton. So rope won't break when monkey climbs down. Any doubt? മക്കളെ ഡൗട്ട് ഉണ്ടോ? ഡൗട്ട് ഉണ്ടോ? നോട്ട് ചെയ്യാട്ടോ. നോട്ട് ചെയ്യാട്ടോ. കഴിഞ്ഞ എഴുതി കഴിഞ്ഞ all of you noted? So next problem, not next problem, next topic, next is a new topic called friction. This is a new topic called friction. See, what is friction? Whenever a body moves or tends to move over the surface of another body, a force comes into play which acts parallel to the surfaces of contact. And opposes the relative motion. This opposing force is called friction. So remember, whenever a body moves or tends to move over the surface of another body, there will be an opposing force. That opposing force is called what? Friction. Okay. Now why there is friction? Next topic, cause of friction. Force of friction. Why friction happens? The force of friction. The force of friction is due to atomic or molecular forces of attraction. Forces of attraction between the two surfaces. Between the two surfaces at the point of actual contact. At the point of actual contact. Why we say like that? See, suppose one surface moves over the top of another surface. See, these surfaces are moves parallel. So what happens? There will be a force which opposes this relative motion. That opposing force is called friction. Now, why there is friction? See, when you see this, you will think that okay, two surfaces are smooth, polished. But if you go to the micro level, that if you zoom it, you can see there will be surface irregularities. Due to surface irregularities, there will be an attraction of atoms or molecules. So this attraction will what? Prevent or oppose the motion. This attraction which opposes the motion between molecules is called what? Friction. The smoother the surface, lesser will be the friction. Now, due to the surface irregularities, actual area of contacts will be much smaller than apparent area of contact. Apparent area of contact. Actual area of contact will be what? Much smaller than what? Apparent area of contact. Apparent means namukku thonum, we will see that these two surfaces are smooth. There is a big area between them. But actually, at the micro level, there will be surface irregularities. So, actual area of contact will be much smaller than the apparent means what? Namukku thonunna, what we feel. So, actual area of contact will be what? Much smaller than apparent area of contact. See why I am saying that? No. Suppose there are two surfaces. When we look at the surface, we will see like this. Both are very much polished. But if you zoom this picture, then you can see there will be variation in the micro level. Then what happens? This surface, there is what we call humps. Hump will be there, certain area will be lower, certain area will be higher. So there will be an attraction between molecules. If you zoom this, if first figure, you can see there is a large area of contact. But if you zoom that, we can see that actual area of contact is much smaller than what? Apparent area of contact. At the micro level, there will be attraction between molecules. That attraction between molecules will prevent the motion between the surfaces or will prevent the relative motion. This force which prevents the relative motion is called what? Friction. What is the reason of friction? Due to atomic or molecular level attraction. Any doubt? ഡൗട്ട് എന്താ? നോട്ട് ചെയ്താ? Noted? Done? All of you done? Noted? Agash, all of you done? Next, only Abhinav Arada have done written noted. What about others? Not done? Not finished? Okay, those who have finished, please try to by heart. Next, friction is of two types. Is of two types. What are they? First one, static friction. Then kinetic friction. F suffix X stand for static friction. Second one, kinetic friction. Remember, kinetic friction is divided into two. Kinetic friction is divided into two. Rolling friction, and the second one, sliding friction. Remember, rolling friction is always lesser than sliding friction. So if you want to move an object, it's better to roll it, sliding friction. Or what we will do? We will be attaching wheels to that object. If the object is attached to wheels, wheel means what? It will roll. So rolling friction is lesser than what? Sliding friction. There is a question. Why discovery of wheels is one of the most important discovery of mankind. Most important discovery of mankind. What is the answer? Answer is very simple. What is the answer? Rolling friction lesser than sliding friction. Wheel means what? It will roll. Rolling friction is lesser than sliding friction. Suppose you have a very big almara in your house. If you want to move that almara, what we will do? We will be attaching small wheels to that almara. Then you can easily move that. Why? Because rolling friction is lesser than sliding friction. Any doubt? Note it down. Done? Noted, right? All of you noted, right? Our next topic, static friction. Next topic, static friction. Next topic, static friction. It is the frictional force. It is the frictional force between two surfaces in contact before there is a relative motion between the surfaces. Before there is a relative motion between surfaces. Before there is a relative motion between surfaces. So remember, what is static friction? It is a frictional force between two surfaces in contact before motion starts. So static friction always happens before the motion starts. There is a very important graph here. See, applied force is on the x-axis. Applied force is on the x-axis. And y-axis we have friction. See, when the applied force increases, static friction also increases. So this side we have what? Static friction. Now, just before motion starts, static friction reaches its maximum value. This is called limiting friction. Limiting friction. Just before motion starts, static friction reaches its maximum value called limiting friction, or you can say maximum value of static friction, or maximum value of static friction. It is denoted by Fs max. Denoted by what? Fs max. Then once the motion starts, then here we have kinetic friction. Here we have what? Kinetic friction. This is what? Fs max. This point Fs max. Kinetic friction is denoted by Fk. Static friction denoted by Fs. I hope it is clear for all of you. So now remember, suppose I am placing this mobile phone on my hand. I am applying a force. When the applied force increases, static friction also increases. See, now there is no force, no applied force. Phone is at rest. Here I am applying a force. So what happens? Static friction also increases. When the applied force increases, static friction also increases. So static friction is called self-adjusting force. It's a very important question. Why static friction is called self-adjusting force? Self-adjusting force. When the applied force increases, static friction also increases. When the applied force increases, static friction also increases. That is understood from the graph. When the applied force increases, static friction also increases. So, Static friction is called what? Self-adjusting force. It's a very important question. So static friction is called self-adjusting force. Self-adjusting force. Now you can explain what is limiting friction. Limiting friction. When the applied force increases, static friction also increases. Static friction also increases. Now, just before the motion starts, see again, I am placing my mobile on my hand. I am increasing the applied force. Static friction also increases. Just before motion starts, static friction just before motion starts, static friction reaches its maximum value. Static friction reaches its maximum value called limiting friction. Maximum value called what? Called limiting friction. Just before motion starts, static friction reaches its maximum value called limiting friction. Limiting friction is what? Fs max. Fx max. Now remember, writing here, Fs max directly proportion to normal reaction. It's very important. Fs max directly proportion to R is what? Normal reaction. Fs max is equal to mu s R. What is this mu s? Mu s is equal to coefficient of static friction. What is mu s? Coefficient of static friction. What is mu s? Coefficient of static friction. Any doubt? Any doubt? This graph is very important. Now, from the graph, next point, from the graph, we can understand that kinetic friction is lesser than normal static friction. Kinetic friction is lesser than maximum value of static friction. Maximum value of static friction. Any doubt? This graph is important. The graph is very important. മക്കളെ ഡൗട്ട് ഉണ്ടോ? ഇത് ഇമ്പോർട്ടൻ്റ് ആണ് കേട്ടോ. നോട്ട് ചെയ്യട്ടാ, നോട്ട് ചെയ്യേ. I should add one more point. Fk, that is kinetic friction, is lesser than Fs max. Kinetic friction is lesser than maximum value of static friction. All of you done? Noted? Noted, right? Others noted? And also note one point. Fs, static friction can be lesser than equal to Fs max. Also note down this point. Static friction can be lesser than or equal to Fs max. Static friction can be lesser than or equal to Fs max. All of you done, I think. Okay, continuing. Next, laws of static friction. Laws of static friction. Laws of static friction. First law, the magnitude of the limiting friction, that is maximum value static friction. Magnitude of the limiting friction is independent of area of contact. Independent of area of contact. Second law that we have already know, Fs max directly proportional to Fs max directly proportional to normal reaction. Fs max is equal to mu s r. Mu s is equal to what? Fs max by r. Mu s equal to Fs max by r. So what is mu s? Coefficient of static friction. Ratio of coefficient of static friction is the ratio of maximum value of static friction to normal reaction. Maximum value of static friction to normal reaction. Maximum value of static friction to normal reaction. That is MUS. Maximum value of static friction to normal reaction. These are the laws of static friction. So what is the first law? The magnitude of limiting friction is what? Independent of area of contact. That independent is very important. Magnitude of limiting friction is what? Independent of area of contact. Note here, laws of kinetic friction. Note ചെയ്തില്ലേ? Next, kinetic friction. Next, kinetic friction. Next, kinetic friction. The force of friction which comes into play when a body is in a state of steady motion over the surface of another body is called kinetic friction or dynamic friction. So if a body is in motion, we call that friction as kinetic friction or dynamic friction. We know that kinetic friction is, what is the next very important point? Kinetic friction is always less than limiting friction. Kinetic friction is always lesser than limiting friction. Kinetic friction is of two types, sliding friction and rolling friction. That kinetic friction, two types, what are they? Sliding and rolling. Sliding friction, rolling friction, that is already explained. Rolling friction. Now next, laws of kinetic friction. First one, the kinetic friction has a constant value depending on the nature of two surfaces in contact. Please note down, depending on. Static friction, it was independent. Depending upon what? Nature of surfaces in contact. Then, second law, kinetic friction is directly proportional to normal reaction. Directly proportional to normal reaction. So Fk directly proportional to normal reaction. Fk is equal to what? Mu Kr. What is mu K? Where mu K is the coefficient of kinetic friction. Mu K is the coefficient of kinetic friction. Please don't forget mu K is coefficient of kinetic friction. So what is mu K? Mu K equal to Fk by R. Mu K equal to what? Fk by R. Mu K is equal to Fk by R. Now we know that Fk lesser than Fs max. What is Fk? Fk is what? Mu Kr. What is Fs max? Mu Sr. R are gone. So we can write what? Coefficient of kinetic friction is lesser than what? Coefficient of static friction. Coefficient of kinetic friction is lesser than what? Coefficient of static friction. അത് മനസ്സിലായോ? ഡൗട്ട് ഉണ്ടോ? ഡൗട്ട് ഉണ്ടോ? ഡൗട്ട് ഉണ്ടോ? നോട്ട് ചെയ്താ? ഡൗട്ട് ഉണ്ടോ? നമ്മളിപ്പോ നോക്കണത് എന്താ? കൈനറ്റിക് ഫ്രിക്ഷനാണ്. നോട്ട് ചെയ്യട്ടാ, എല്ലാം നോട്ട് ചെയ്യേ. ലോസ് ഓഫ് കൈനറ്റിക് ഫ്രിക്ഷൻ പഠിച്ചു, ലോസ് ഓഫ് സ്റ്റാറ്റിക് ഫ്രിക്ഷൻ പഠിച്ചു. നമ്മൾ ലാസ്റ്റ് എന്താ പ്രൂവ് ചെയ്തേ? കോഎഫിഷ്യന്റ് ഓഫ് കൈനറ്റിക് ഫ്രിക്ഷൻ ഈസ് ലെസർ ദാൻ വാട്ട്? കോഎഫിഷ്യന്റ് ഓഫ് സ്റ്റാറ്റിക് ഫ്രിക്ഷൻ. നോട്ട് ചെയ്യട്ടല്ലേ? നോട്ട് ചെയ്ത് എല്ലാവരും? ഓൾ ഓഫ് യു നോട്ട്. നെക്സ്റ്റ് ടോപ്പിക് ആണ് ആംഗിൾ ഓഫ് ഫ്രിക്ഷൻ. Angle of friction. This is the next topic. There is a surface and I am placing a box on top of the surface. Its weight mg is acting vertically downward. Normal reaction is acting vertically upward. This side I am applying a force, so I am writing F applied, force applied. So friction act in the opposite direction. Here I write Fs max. Why I am writing Fs max? Because this picture is taken just before motion starts. Just before motion starts, static friction reaches its maximum value called maximum value of static friction. So that is the reason why I am writing Fs max. Now what will be this? This diagonal will be the resultant of the resultant of Fs max and normal reaction. This diagonal will be resultant of Fs max and normal reaction. And this R is what? Normal reaction. And this angle is what? Angle of friction. So why this is resultant? Because we have already seen the parallelogram law of vector addition. If two vectors are represented by two adjacent sides of a parallelogram drawn from a common point, then the resultant will be what? Diagonal of the parallelogram drawn from the same common point. Isn't it? So what is this diagonal? It is a resultant of Fs max and normal reaction. If somebody is asking me what is angle of friction, my answer would be it is the angle between resultant of Fs max and normal reaction, that is this one, with the normal reaction. What is angle of friction? Angle of friction is the angle between resultant of maximum value of static friction and normal reaction maximum value static friction and normal reaction with the normal reaction. Now what is tan theta? Opposite side by adjacent side. What is opposite side here? See, this will be the opposite side. So if I move my hand like this, I can understand that opposite side equal to what? Fs max. What is the adjacent side? Normal reaction. And I know that Fs max directly proportional to normal reaction, and Fs max is equal to what? Mu SR, coefficient of static friction into normal reaction. So what is tan theta? Instead of Fs max, I can write mu SR by R. So R gets cancelled. So what is angle of friction theta? Tan inverse mu S. Any doubt? മക്കളെ ഡൗട്ട് ഉണ്ടോ? ഡൗട്ട് ഉണ്ടോ? എഴുതിയാ? ആരതി നോട്ടെടുന്ന് പറഞ്ഞു, ബാക്കിയുള്ളവർ എഴുതി കഴിഞ്ഞോ? Okay, all of you noted down. So we are done with angle of friction. Next is angle of repose. Next, angle of repose. This is the next topic, angle of repose. It is defined as the minimum angle. It is a minimum angle that an inclined plane makes with the horizontal when a body placed on it just begins to slide down. So we will see, this is an inclined plane. I am placing a body on top of this inclined plane. Its weight mg acts vertically downward. Normal reaction will be normal to the position. So this is the normal reaction. Now, see, the weight can be resolved into two components. Suppose this is angle phi, then this will be what? Mg cos phi, and this will be what? Mg sin phi. What is this topic? Resolving vector into rectangular components. If this is angle phi, this is also what? Angle of repose phi. Now, in which direction friction acts? Friction acts in this direction. Why I am writing Fs max? Because this photo has taken just before this box slides down. Once it starts sliding, it is kinetic friction. Just before sliding, static friction reaches its maximum value, called maximum value static friction. That is the reason why I have written Fs max. Any doubt here? Any doubts? Any doubt? മക്കളെ ഡൗട്ട് ഉണ്ടോ? So what is definition of angle of repose? It is a minimum angle that an inclined plane, this is an inclined plane, makes with the horizontal. So what is this angle phi? When a body placed on it just begins to slide down. What is angle of repose? It is a minimum angle that an inclined plane makes with the horizontal when a body just begins to slide down. So we should write mg sin phi is equal to what? Fs max. Mg cos phi is equal to what? Normal reaction. This is equation 1, this is equation 2. Equation 1 by equation 2 means what? Mg gets cancelled. Sin phi by cos phi is what? Tan phi. Tan phi is equal to what? Fs max by R. Now I know that Fs max directly proportional to what? Normal reaction. And I know that Fs max is equal to what? Mu SR. So tan phi is equal to what? Mu SR by R. So R gets cancelled. So tan phi is equal to what? Mu S. So what is phi? Angle of repose. Tan inverse mu S. This is angle of repose. Earlier we had seen angle of friction. Angle of friction theta is equal to also what? Tan inverse mu S. That is angle of friction is equal to angle of repose. Angle of friction is equal to what? Angle of repose. Any doubt? Sir, horizontal component എപ്പോഴും cos അല്ലേ? എങ്ങനെയാണ് sin വന്നത്? എനിക്ക് മനസ്സിലായില്ല. No. See, this is the horizontal. This is the horizontal. See, with the horizontal, it is making an angle phi. So this is mg and this is mg cos phi. This is the horizontal. Making an angle phi with the horizontal. Note down angle of repose. Note ചെയ്താ? Continuing. What is the principle behind the use of ball bearing that you have seen in cycles? The wheel rotates through what? See, this will be the wheels, and when the wheel rotates, inside that there will be what? Ball bearing. What is the reason behind that? Rolling friction is lesser than sliding friction. Rolling friction is lesser than sliding friction. So that is the reason why we are using what? Ball bearings. Then you can expect a question. Why friction is called necessary evil? Necessary evil. Reason: friction has many advantages and some disadvantages. So friction has both advantage and disadvantage. So it is called what? So it is called necessary evil. Necessary means we need that. Evil means we do not want. In certain situations we require friction. In some other situation we don't want friction. So it is called necessary evil. Necessary evil. Then how to reduce friction? How to reduce friction? How to reduce friction? Options, not answer: polishing, smoothening, then usage of lubricants. These are the different methods through which you can reduce friction: polishing, smoothening, and the use of lubricants. Done. Done. Noted. Okay, next. Advantages of friction. Advantages of friction. First one, we are able to walk. We are able to walk on the ground due to friction. Ground due to friction. It is self-explanatory, so no need of further explanation. We can hold an object in our hand due to friction. Due to friction. Then, third one, the brakes of a vehicle works due to friction. Due to friction. Brakes of a vehicle work due to friction. Next, disadvantage of friction. Disadvantages of friction. Wear and tear. Wear and tear. മലയാളത്തിൽ പറയുന്ന പേരാണ് തേയ്മാനം. തേയ്മാനം. Wear and tear of the machinery. Is due to friction. Wear and tear of the machinery is due to friction. Then, when a vehicle moves, a lot of energy is lost. A lot of energy is lost to overcome friction. We have to spend a lot of energy to overcome what? Friction. Then, friction caused by atmospheric air is disadvantages due for rockets and satellites. So for these advantages and disadvantages, we call friction as necessary evil. So we call friction as what? Necessary evil. Done? So next class, Please note it down. Next class, we will discuss two important topics. That is maximum velocity on a circular level road and maximum velocity on a banked road. And then we will be doing problems related to that. By the next class, I will be finishing this chapter. Okay, please note down. Please note down. I hope all of you have noted down. So thank you, students. We will see you in the next class. Next class, maximum velocity on a circular level road and also banking off road. That is tomorrow's class. Thank you.